Hey everyone, welcome back to the shop. And it's an exciting day for me here because today we're going to be putting our new Miltronics SL8 CNC lathe to work on our very first customer job using the SL8. And behind me you can see we've actually got a workpiece in there. This is some of my testing and tuning that I've been working on behind the scenes. You can see the part here on the controller there as well. And we'll get into that and talk a little bit more about what it is that we're going to be creating. But I have been spending a little bit of time getting the machine set up, getting our tool setter properly calibrated. We've got the turret filled up with tools and had to get all those calibrated. And then I've just been spending some of my own personal time getting familiar with the machine and getting more comfortable operating this. I will say that it does make me nervous every time I get on the CNC lathe and operate it, just because it's, you know, you get the jitters whenever you're new at something and you don't want to crash it, you don't want to tear it up. And it seems like the CNC lathe induces a little bit more stress on the operator, for somebody like me anyway that doesn't have a whole lot of experience with it. But once you get in there and you start proving the tool pass and you don't make any stupid errors and crash anything, you start building that confidence, especially after you see it cut the first part and you know that it's just going to do what you told it to do, and it's going to repeat and keep making parts. So I'm happy to say that we have a great program that I know is working, and once I made a few of them, and in fact this is the part that we're going to be making right here. And I've got a few of them turned out of 1018 steel. This is just scrap steel that I've had here, drop steel if you will, and I've just been using that to get the program proven, get our thread dimension on size, and just make sure everything is working good. And well, I'm going to show you, we're going to machine a couple more of them out of steel, but we're going to be moving on, and the material that we're going to be machining these out of is actually brass. That's what they need to be machined for the customer. So just been using this steel to kind of get the program proven, all of my tools set, and everything that I know is it's in order. So we're at the point now where I'm ready to start feeding material and start machining these parts. But let's back up just a minute and mention what this is going to be used for. So later in 2025, towards the end of the year, I was contacted by somebody by the name of Paul, and he works for the North Carolina State Parks Service. All right, he is a park ranger, and he works at, or the job that we are doing this for is Fort Macon State Park, and they are in Atlantic Beach, North Carolina. We've personally never been to that state park, but now that we know about it, we're actually looking forward to visiting this. And maybe after we complete this job, some of you guys might be interested in going by there and seeing if you could find these guys out there in the state park. But anyway, Paul had reached out to me and told me that he and a group of people there that's kind of part of the state park system, it's a friend group that get together, and they work on restoration projects for the park service there. What they are working on, they are building replica cannons that replicates the same exact type of cannon that was used in 1862. I don't know anything about the history of that fort, but he says there was one battle there that took place, and it was in 1862. And they are wanting to, what they are doing is they're building replica cannons there for the park. And they have been machining most of the parts themselves. Paul has. He says they set up a small machine shop there, and he's been doing a lot of the basic machine work that he could do himself to help build the parts for these cannons, and I'm sure other things there as well. But what he had reached out about was these handles. All right, he said that this would most likely be a better job done on a modern CNC lathe to get these things done. You see, you got this profile here. So what this is a handle for the elevation screw that is on these cannons. And he showed me some pictures. I've got some photos we'll throw in the video there so you guys can see exactly what this is for. But on the back side of the cannon, there is a vertical elevation screw and I didn't get specifics on sizes. It looks like it's maybe about 2 inches in diameter. Looks like it's probably a square thread. But anyway, there are, on that elevation screw, there's a total of 4 of these handles screwed into the elevation screw to make it look more of like a ship's wheel, if you will. And the operator of the cannon takes these 2 handles and you rotate that screw to adjust the tilt of the cannon. That's how they get it to aim. I don't know the perfect definition of what some of these terms should be, but it's an elevation screw so they can adjust the pitch of the cannon. So this was the part that he asked for some help doing, is making these handles right here. And we give them a quote. They were real happy with it, and they decided that they wanted me to machine 24 of these handles. I guess they've got quite a few of these cannons that they're going to be building, and it takes 4 handles per cannon. All right. So I am happy to help with this project. This is a perfect job for our CNC lathe, and it's doing a beautiful job. And I'm excited to go ahead and get started on this, and I wanted to get the camera fired up and bring you along for the journey and show you the process that we're going to be using to get this job done. This is going to be a 2-operation job. First operation is going to be over here in the CNC lathe, just like you see there. And then what I'm doing, I do have a parts catcher on this lathe, but the parts catcher isn't long enough. It's not big enough to catch this handle, and I didn't want to risk damaging the surface of this trying to catch it in that small parts basket. But at the same time, I don't think it would fit in the box here. This is a box that the parts catcher flips the parts into and catches it so that you can retrieve it. So what I decided to do was turn this thing and just leave about 100 thousandths on the back end here, and we'll retract the tailstock, and I just reach in there by hand and just simply break it off. All right. So the second op, this is going to be a separate video, by the way. We're going to set this up in our CNC mill. I'm going to machine some soft jaws to hold this guy, and we'll come in there and we'll face this nub off on the end, make a nice finish on the end of it. And I asked if I could put my logo on the end of the handles, and they thought that that was a great idea. It's like a little Easter egg that, you know, the folks that watch the channel that see this done, if you go out there and visit the park, whenever these are installed, you'll be able to see the actual handles that we machined here for the cannons. So we'll work on that as a second operation. I've got to, again, I got to machine some soft jaws to be able to hold it, and we'll get to that later. So today, let's focus on the CNC lathe and get this guy done. I'd like to machine one more of these in steel because it's working really well, and I'd like to get some video to share with you that. And then I've got 2 links of brass over there that we've got to get cut off in the saw. I'm going to be cutting approximately somewhere between 3 and 4 feet, and we will slide it through the back side of the lathe here. I did install a spindle liner recently, and that was specifically for this job. We're going to be using 1¼ inch diameter brass. So that's the size spindle liner that we installed. So we'll have a long piece about 4 foot long that we can slide in there and do our machining. And then once one is broken off, we'll be able to start the process again. It's going to face it, center drill it. The program's going to stop. I've got a work stop in there that's going to drop down. We'll unchuck the material, slide it out to the work stop, chuck it, and then hit cycle start. It's going to move the work stop out of the way. It's going to extend the live center, and then it's going to finish turning this guy. So excited to share it with you. So let's go ahead and get started on it. I don't believe we have covered the SL8 in a video yet other than the install. And I remember we did a Tool Tuesday talking about the new coolant nozzles that we installed on here. But this CNC lathe comes equipped with a hydraulic operated chuck as well as a hydraulic operated tailstock. Now you have to move the tailstock, you have to position it where you want to. There's a little pawl here that will catch the movement of the tool turret there so that you can move this where you want to, and then you have these bolts that clamp it down in position. And then you simply, you have a couple of foot pedals there. One's for the chuck, one's for the tailstock. And if you push the foot pedal, use that to extend, and also I'm sorry, retract and extend. I said that backwards. So there's your retract, and then there's your extend. Same thing for the chuck. And I only have the soft jaws for this chuck right now. I need to get some hard jaws for it, but these are going to be perfect when we want to machine the jaws to hold specific parts there. All right, it has a 12 tool turn on it. We do not have live tooling on it. We also don't have a sub spindle on there. I've had some people ask me about that. But we got the tool turret loaded up with a bunch of our Walter and Tungalloy tools, and they're all working beautifully. We've got a center drill in there. And then this one right here, which is tool 7, this is just a piece of an aluminum block that I put in there. And this is being used as our work stop, and you guys will see that operate. I still have a few pockets open over there where you can put some more boring tools in there, or take those off and put more turning tools if you want. I had mentioned a parts catcher right here. This is the parts catcher basket here that will flip out and catch your part, and then it comes down and flips it into this box so that you can just keep running the machine and just reach in here and grab your part whenever it's finished. Of course, we have our wash down nozzle, our air hose there, and I think that's about it. I did mention we installed a spindle liner that was we bought that from Trusty Cook. You might be able to come around here and see it on the back side there. So we took the panel off so I can feed the bar in there. But Trusty Cook builds those spindle liners for pretty much any CNC lathe out there, whatever size you want. So that worked out pretty well. And I think that just about covers it. Besides our tool setter, this is the tool setter right here. So you can flip this guy down and use this to touch off all of your tools. You got to be really careful that you don't flip this down with a piece of material in there, because then it's going to damage something. All right, and it does have the chip conveyor on this machine there as well. There's a little bit of the chips from our testing and tuning that we've done. So a really nice feature to have that on here. All right, let's get into our work, shall we? So this is one that I just finished machining, and I was going to just leave it alone because I'm going to show you what the process is from here. And now that we've got this one turned, I'm going to go ahead and show you how we're going to be doing this. All right, so now that the job is done, this is the end of the program. I'm going to manually retract the tailstock with the foot pedal there. All right, and then reach in here by hand and just wiggle this just a little bit, and it just breaks it right on off. And there's your finished part. All right. Set this down on the table. There's the other ones that we've worked on right there. So what we've done, what I wanted to be able to do was at this point right here, I want to be able to face this, center drill it, pull it out here where it needs to be, and then extend the center, and then be able to use our tools and come in here and finish the turning. So this is sort of a two-part operation that's combined into one full operation cycle on there. I had a little bit of help from Miltronics to be sure that I was using the conversational properly to get the first part of the program done. And once that part is complete, the program pulls up a sub-program, which is the handle that we're machining here. And we'll show you the process as this works. So first thing we're going to do is face it, center drill it. This work stop is going to drop down into the position that I want to pull the stock to. We'll use our foot pedal to unchuck the chuck. We're going to manually slide the work out to our work stop. Once we have the stock pulled out against our work stop there, we just hit the foot pedal for the chuck again. It'll clamp it. And then at that point, we shut the door. We hit cycle start where it'll continue. It's going to slide the work stop out of the way. It's going to extend the center, and then it's going to do all the turning and threading and parting there to complete the cycle. Pretty neat operation for me. This is a big deal for me because this is the first time that I've got this involved with CNC lathe work, and it's this kind of stuff, like why I was really excited about upgrading to the SL8, because I thought that this was going to be a little bit better for production parts that we want to machine. I got some other things that I want to make for our own products, and I think this lathe is going to be better for that. So let's get started on it, shall we? So I haven't really figured out the best camera angles for this CNC lathe yet. And the other thing is that I have to operate this with the door shut as well. So I'm trying to figure out how to give you guys the best shot. So just bear with me as we kind of figure that out along the way. I think that's going to work pretty good though. So we're going to go ahead and start. I'm going to run it a little slow to begin with, just to make sure that everything is in fact working like we should, and you guys will get a good shot. So first part, we're going to come in and face it and center drill it, and then we'll pull it back. All right. I'm going to slow my rapid down here so that we kind of approach it slowly. I'm going to change to tool 1. I'm sorry, tool 6. Slow this down. It'll speed up as we get down there closer to it. I've got it set at a max RPM of 2,500, by the way. Gonna make 3 passes on that face. Get rid of that nub. And it's gonna come back. We're gonna move to the center drill. This is a little scary here. Oh, I got an optional stop. Right there, it comes in pretty close to the workpiece. You can see right there, but it will clear. We've got 100,000 clearance there. Probably can't see it from that angle, but it is going to come in. We're going to cut our center, 156 thousandths deep. Our tool is going to retract, move out of the way, and it's going to change to my work stop. That will move into the position. Now I have a programmed stop on the machine here where I can open the door. And this is the manual part of the whole job here. Make sure there's no chips on the face. And then we're going to unchuck it. And look at that. So I'm already messing up. See, I ran out of material there. Man, I thought I had enough there to show you the job. So, all right, I've got another piece of this stock over there. I'm going to go ahead and prep it, and we'll bring it back over here, and we'll start this again. I turned it over in the manual lathe because this was rusty, and I didn't want all this rust getting in here on the machine. So let me get another piece of stock, and we'll try this again. This position against this face of this aluminum work stop, this is our G55. This is G54, which we're using for our conversational program for facing and center drilling it. And in this position here is G55, which is what we have our sub program set to. All right, so we'll unchuck it. Pull it out against the stop there. Just trying to square it up. Chuck it. There we go. Close the door and hit cycle start to continue on. It's going to move the work stop back 20,000 so it doesn't rub the part, and it'll do a tool change to tool number 1. Also extend the tailstock. Just like so. I'm going to bring it in slow again. And I'm not running coolant on this, by the way. We're going to cut it dry. So this is a DNMG tool that we're using. And it's going to turn the end for the 3/4 10 thread. Finish pass, then it's going to cut a chamfer. There's the chamfer. All right, I'm going to do a tool change. And then, so what this is going to be right here, this is tool number 12. This is going to cut our thread relief. It's taking some plunge cuts, and then it'll take a finish pass to clean that up, and then it'll cut a chamfer on the back side of the thread area. Cleaning up both sides, and it'll cut a chamfer right there. Now we're going to do a tool change. So this tool right here, oh, I'm sorry, this is our threading tool. This is our tongue alloy Tetra mini cut. There we go. Threads cut. Now we're doing a tool change. This is tool number 2. So what this tool is here, this is our Walter Groove Tech tool. It's a 4mm button nose tool, full round radius. And this is designed for multi-directional turning and plunging. You can turn or plunge with it, either one. And it's working really good. Maybe it'll get these stringy chips off here whenever we come up. It's going to start at the chuck and go back towards the center. All right, here we go. This tool has really surprised me, and it's worked exactly like they said that it would. We're going to be, so it's feeding at 10 thousandths per revolution, and total depth of cut is 50 thousandths per pass. That's the full 50 thousandths right there. Putting off a beautiful chip. And so this is going to be more of a roughing pass here. It's going to shape the handle where it needs to be. And then we left, I don't remember, it was either 10 or 15 thousandths that I leave on it. And we'll make a cleanup cut at the end just to finish it. Beautiful job. Now it's going to kind of rough out this very end. All right, now it's going to chamfer the end, that corner. Now it's going to make a finish pass all the way across it. There it is. All right, tool change. This is going to be our tongue alloy part off tool. I'm going to bring it in slow because it is a little scary watching that come in. That is the add force cut parting blade. It's going to part it, leave it 100 thousandths there, and that's it. That's the end of the program. And we can open the door. We manually retract the tailstock at this point. And everything looks good. Now, one thing I want to do before I break that off, I'm going to go ahead and give the thread one more check because I did have it where I wanted it on our thread pitch diameter for 3/4 10, and I want to see if it's maintaining that. Yes. I'll do it one more time. These are a little finicky to measure with, but you get the feel right. That's 0.682 on the thread pitch mic. And I've got, this is our dimension here according to the handbook for a 2A 3/4 10. This is your pitch diameter that you're shooting for right there. So I'm measuring at 0.682, so it should be within what we want. And by the way, I do not have a go no-go gauge for 3/4 10. I've got one on order. It should be here in a couple days. This is the no-go gauge. I have this one, but I did not have a go gauge for 3/4 10, and it will not screw on there. So I think we're good there. At this point, I'm just going to grab a rag because that shaft will be a little warm, and just simply break it off, just like that. There we go. Pretty cool, huh? It's cool to me. I'm enjoying it. I'm having a lot of fun with this. All right, so here's the one that you just saw being turned right here. It's still a little bit warm. This is one that we just previously cut, and it's identical to it in every way. That's one of the great benefits of being able to do these types of jobs on a CNC is the repeatability. Of course, you can go to a manual lathe. There's all kind of cool techniques you can use to cut profiles on a lathe, but having the capability of a CNC is about repeatability and getting it done quickly and efficiently, and every single part being absolutely identical to the last. So this is not a gauge by any means, but it is a 3/4 10 flange nut, something that I use on the machines for hold down hardware, and it'll screw on there just like it's supposed to. But because I used my pitch mic and I looked up the pitch diameter in the handbook, I feel confident that we have a good fitting thread on there. So my gauge should be here pretty soon, and we'll be able to check them with that. So anyway, I think that's going to complete our testing and tuning using the steel. So I'm ready to get our brass stock down in the saw, and we're going to get some pieces cut off. We're going to start feeding it in here, and let's start making our brass elevation screw handles. We've got a couple lengths of 1 1/4 360 brass. This is what they wanted to use for this job. And so we'll get it fed into the saw here, and we're going to cut. It's going to be about 3 foot. I'm going to do some calculations to minimize the waste on the end, but we need just enough material whenever we machine the last part that there's enough that the chuck can hold on to it. This is what the last piece will look like once we get to the end of our cut length. So this is going to be our drop material. I want to keep this at a minimum, so this is just going to be like 2 inches right here. Our handles finished length are 7 5/8. I've got them parted off, and we're using a 1/8 wide parting tool, so we need to add 1/8 of an inch to that. And then I left 10 thousandths on the end of this handle that we can face off there. And that is not a critical dimension on that either. If we need to take that down just a little more to clean it up in the mill, that's not a problem. So we're going to figure 7 3/4 times 4. 7.750 times 4. That's 31 inches. Let's add 2 inches of this to be able to hold on to for the last part. So plus 2, that's 33 inches. I'm going to start with that. I'm going to see how the machine reacts to a 33-inch long piece of material, and if we need to bump that up to get a 5th or even 6th part out of that, we can do that too. So we're going to do a cut length of 33 inches. All right, so let's do 33. And that looks like that's a bandsaw cut on the end of that, so it's gonna be faced off anyway. So 33 inches is what we'll start with. Again, I'm sure we can do more than that, but I'm gonna start here, just work our way up. By the way, bandsaw blade is messed up. I've got some messed up teeth on it, and it's a chore to change this blade out. I don't feel like doing it. I think it'll cut through this brass okay, so let's see how it does. Go ahead and speed it up. Let's see if it'll handle brass. I accidentally cut a piece of induction hardened steel. I didn't realize it was hard, and it messed up a couple of the teeth, and you might be able to hear it. It's cutting this brass okay though. That's going to work just fine. We'll go feed this into the lathe now. All right, stick it through the spindle liner here. Almost there, so I got to use a broom handle to get it all the way through there. So I will be using this to push the material. Obviously we don't have a bar feeder. Maybe one day we'll be able to hook one up to this machine. All right, and we want about a 1/2 inch sticking out of the jaws here to start with. Tighten the chuck. Yeah, it sucked it back in there. All right, there we go. There's a 1/2 inch, so it should face that right there. Before I cut the brass, I think I'm going to go ahead and turn the conveyor on and try to get at least as many of the steel chips out of here as we can. I need to blow some of these down, so I want to try to get most of the steel chips out of here so that we can collect the brass separately. So I'm going to work on that right now. Let me blow some of these down here, and then I'll show you the conveyor running. All right, I think we got most of the steel chips down there. You have to shut the door to run the conveyor, but it's just easy enough. You hit auger, and I can see right through here. You might be able to see that moving there. And it'll bring it up here and dump them into this can. Like a rain shower of chips. I think that's going to be the bulk of them right there. I know it's not going to, we're still going to have chips mixed with the brass, but at least I got most of the steel out of there anyway. Since this is new to me, I've got to figure out the best way to clean that conveyor. Maybe just right here with a brush. I might do that. Just sit here and take a minute and go ahead and brush that conveyor off. I'll have to see what other people are doing to kind of clean these conveyors off to separate the different materials. So far this is working fine for me right here though. All right, I think I've got that conveyor pretty well cleaned off. The problem is that it's still got the shipping oil, or the cosmoline if you will, still on it, so I really need to wash it off with some solvent and get that cleaned off. But I think it's cleaned up good now. When we get through with this job, I'm going to take I got another one of these cans. I'm going to wash it really good, and we'll use that for our brass chips. And I'll take a big magnet and run through there and try to collect any of the steel shavings out of there once we get to that point. But I think I'm ready to get moving on it. So let's go ahead and get started on our first brass Cannon elevation handle. This is going to be the first time turning the brass, and I don't know how the inserts are going to react to cutting brass. I'm assuming that it's going to be just fine. It's going to handle it no problem, but we'll find out here in just a minute. Let's get started on it. It thinks there's a nub there, that's why we've got it set to that. Those 3 passes, I mean. There's our center drill. Oh, cycle start. I'm gonna turn that optional stop off. No problem there. All right. Unchuck it. Tighten it up. There it is. Cycle start. All right, here we go. Finish is a little questionable at this point. We'll get through the first one and see what we need to do. All right, here's our groove tech. Now that's got a little bit of a squeal to it. I'm gonna have to put my earplugs in, guys. So far, so good though. Chamfer and finish pass. Parting tool. In the program. All right, we're gonna take a look and see. All right, the finish there looks beautiful. I'm gonna check the diameter of the threads and see how that is, and I think that's gonna be just fine. I was concerned about the finish turning this diameter, but you can't even see that now. I think I was running too fast of a feed rate there with the particular tool that we're using to turn that. This needs to come down. You can see it's not quite cleaning this up right here. So I think what I will do is we'll make an X wear adjustment on that one tool and bring it down just enough so that it'll clean this area up right here. Again, these diameters are not critical, and they even told me that's not critical. This is more of a visual than anything. The most accurate thing we need to focus on is the threads and this face right here being perpendicular to it. But I'm happy with it so far. So it looks like just one slight modification we need to do on our depth for our turning tool. I'm going to go ahead and get a measurement on our thread pitch diameter and see where we are, see if it's matching what we were cutting in the steel. These are so touchy. Got to get the right feel there. That's measuring 682. I think 683 was the top of our limit. Yeah, 682. I'm going to hit it one more time just to make sure that I'm .682. I think we're good on our thread. So I'll make that one adjustment on our Groove Tech tool. Let's see what that's measuring right there. All right, that's going to be 248. I'm going to I'm going to make a 3/1000 adjustment on our X wear, and I'll run it again and see if it'll clean up this shoulder area right here, clean up the stock. We just want to clean it up is all. Now, because I only want to use that one tool to make that pass, I had to load up a separate program. I posted out the chamfer and the finish pass, and I've got that loaded up to run, so it'll just make that one pass without doing everything else. But I need to make my adjustment on the tool, so to do that, we're going to go to parameters and tool table, and that's going to be tool number 2, this guy right here. I want to look in here and make sure. Yep, the Groove Tech is tool number 2, and X wear right here, we're going to put a negative 0.003 thousandths. That should pull the tool in 3 more thousandths, and hopefully it'll clean up that. All right, so now we'll run that, see if it'll clean that OD up. All right, let's try it again. There we go. I think we got it that time. Awesome. Give it a look and see. Yep, got that flange cleaned up. So luckily that's just a feature that's not, it's not critical. It's not matching up to any diameter or anything. Let's see where we're at. Yep, so we are at 1.244 to be exact on that. So we'll just focus on this tool doing this job here, and when we get through with it, I'll move that back out to 0 on our tool table there on our wear offset. But that's looking good. Our thread diameter we already know is good, so I think from here let's go ahead and break it off. Is it warm? No, it ain't warm. All right, let's move our tailstock back and see how easy it is. Yep, broke that little nub off right there. And then again, you can see how much we've got sticking out there. That's why we've got it programmed to take a total of 150 thousandths off, because sometime when I was doing the steel, this pip here was still stuck on that, so I needed to take about 150 to clean it up completely. But anyway, there we go. There's our first brass handle. I don't really like the looks of that. I think I've got too much pressure on this, so I think I'm going to reduce our hydraulic pressure on the live center. I didn't notice that until just right now, so that it won't push that brass out like it's doing there. Other than that, I'm happy with it. So to adjust our tailstock pressure, you can see I've got it kind of set to the max there. It may be just a touch over. Open up this panel here, and you've got your hydraulic valves there. So this one's for the tailstock. Let's take it down to 100. How about that? That's extended. 100 psi. Let's give that a try and see if that helps out. Okay, part number 2. Let's run this one complete. All right, another successful run, but this one too, just like the first one, it had a little bit of run out on this side right here. So I'm gonna have to make another pass across this to clean this up right here. I'm gonna drop the, I'm gonna bring the tool in probably another 2/1000ths and see if it'll clean that up. Thankfully, like I said, this diameter and this diameter here does not matter. It's just strictly cosmetic at that point. So I'm gonna do that off of camera, and then I'll bring you guys back. All right, we've got that cleaned up there. Took another couple thou down. Still getting some unneeded pressure on that center there. So I reset that to 100 PSI. I'm just gonna keep dropping it down 10 or 20 PSI at a time and see if it'll eliminate that over amount of pressure that it's putting on that center right there. Not bad, but it's certainly, I don't like that. We'll just drop it down about 20 PSI and do it again. So, all right, that's handle number 2. You guys have seen it. I think from here, I'd like to try to get some better video, more close-up, clearer shots with my other camera, and just keep ticking along and getting 24 of these guys made. That's number 10. We're gonna keep it going. By the way, I finally have better luck on the center there. What I did was I increased the pressure on the hydraulic chuck by a little bit, and it seemed to clear up this issue. So I think I didn't have quite enough pressure on the chuck, and the center was actually kind of forcing it back just ever so slightly, enough to mar up that center there. But anyway, we got that corrected and everything's rolling good now. So we're just going to keep pumping them out. Okay, so we just finished part number 12, so we're halfway through, got 12 more to go. I'm going to grab the piece in the saw there. It's 44 inches long. It's going to allow me to get 5 parts with, I think, approximately about 4 or 5 inches left over. That little bit of extra length there, there is a little bit of clearance inside that spindle liner. It still allows it to shake around just a little bit, and that's what I was hearing right there. Right at the very end of the spindle liner. Seems to do better with the higher RPM. This is handle number 23. 24. Yep, I'm gonna make one for me to keep here. I like, whenever I do the CNC work, I always like machining whatever it is I'm machining. I like to have one just for my own keepsake. I've got a little collection of things that go into a cabinet, and I just like having records of stuff that I've made. So I'm gonna make number 25, and then that'll wrap up the lathe work here. Well, that is going to wrap up the first operation for our new brass handles here, the lathe work, operation 1. And I got to say, I'm real happy with the results. I think they look great, and it's been awesome getting over here on our new SL8 CNC lathe, operating it, running it, and getting a little bit more familiar with it, how it functions, and all that good stuff that you got to really understand whenever you get a new machine. And I think it did a great job on the handles, and I'm just really happy with it. I hope Paul and all the other fellows up there at the Park Service like them as much as I do, and hopefully they look good with those elevation screws whenever they're put in there and they're installed and those cannons are finished. So overall, I think it just did a really good job on it. So I think that's going to wrap it up. And we're going to have a second video. So next operation, we're going to move over here to our CNC lathe. And what I need to do is I want to machine a couple of soft jaws. My plan is to clamp this vertically. So I'd like soft jaws so we don't mar up this finish, don't put any marks on it. And we'll come in and just touch off the top of that, machine that nub off of it, make it a clean face. I'd like to engrave my logo on there. And then once we do, that'll finish these handles here, okay? I want to give a thanks to Steve up at Miltronics. He helped me ensure that my conversational program was operating correctly, that I wasn't going to have any mistakes or crashes. And then he also taught me on this job how you can combine a conversational program in the Miltronics controller with a sub program, which was my Fusion program, to turn these guys. That was something new to me on this job, and now that I see how that works, it's going to help out on future projects and future jobs. I really like being able to do that. You know, something very simple that we're doing where you just have some stock and you want to face it, center drill it, maybe do some little basic feature. And then what we had here, where we had this you know, turning program, and we combined the two together, and it worked out really great. So thank you to Steve and also Kevin up at mechanicaladvantage.com. He jumped on line with me and helped me fine tune my tool pass there to make it run more efficient, clean up our clearances and things like that. It's all stuff that I'm continuing to learn and try to and be better at and get better at it, so that I can just be more efficient when it comes to all this CAD and CAM work. All right. So I hope you enjoyed the project, and thanks for tuning in and joining us and following along. And I hope you come back to see the completion of our new brass handles for the replica cannons. All right, we'll see you guys later.